Look up.
Our ancestors understood origins by extrapolating from their own experience. How else could they have done it? So the universe was hatched from a cosmic egg, or conceived in the sexual congress of a mother god and a father god, or was a kind of product of the Creator's workshop, perhaps the latest of many flawed attempts. And the universe was not much bigger than we see, and not much older than our written or oral records, and nowhere very different from places that we know. We've tended in our cosmologies to make things familiar. Despite all our best efforts, we've not been very inventive. In the West, heaven is placid and fluffy, and hell is like the inside of a volcano. In many stories, both realms are governed by dominance hierarchies, headed by gods or devils. Monotheists talked about the King of Kings. In every culture, we imagined something like our own political system running the universe. Few found the similarity suspicious. Then science came along and taught us that we are not the measure of all things, that there are wonders unimagined, that the universe is not obliged to conform to what was considered comfortable or plausible. And again, if we're not important, not central, not the apple of God's eye, what is implied for our theologically based moral codes? The discovery of our true bearings in the cosmos was resisted for so long and to such a degree that many traces of the debate remain, sometimes with the motives of the geocentrists laid bare. So, what do we really want from philosophy and religion? Palliatives? Therapy? Comfort? Do we want reassuring fables, or an understanding of our actual circumstances? Dismay that the universe does not conform to our preferences seems childish. You might think that grown-ups would be ashamed to put such disappointments into print. The fashionable way of doing this is not to blame the universe, which seems truly pointless, but rather to blame the means by which we know the universe, namely, science. Science has taught us that because we have a talent for deceiving ourselves, subjectivity may not freely reign. Its conclusions derive from the interrogation of nature, and are not in all cases pre-designed to satisfy our wants. We recognize that even revered religious leaders, the products of their time, as we are of ours, may have made mistakes. Religions contradict one another. On small matters, such as whether we should put on a hat or take one off on entering a house of worship, or whether we should eat beef and eschew pork or the other way around, all the way to the most central issues such as whether there are no gods, one god, or many gods. If you lived 2 or 3 millennia ago, there was no shame in holding that the universe was made for us. It was an appealing thesis consistent with everything we knew. It was what the most learned among us taught without qualification. But we found out much since then. Defending such a position today amounts to willful disregard of the evidence and a flight from self-knowledge. We long to be here for a purpose, even though, despite much self-deception, none is evident.
If you're somewhere dark enough, away from the glow of cities, you can see about 6,000 stars with your naked eye. Some are blue, some are red, some flicker, some hold steady. They look permanent. They look like they've always been there, and always will be. But here's something to sit with. The light entering your eyes right now left its source years ago. Decades, centuries, in some cases millennia. The star you're looking at isn't where it appears to be. It isn't even when it appears to be. You're seeing a message sent long before you were born, finally arriving at your retina tonight. And some of those stars, a small fraction but some, may no longer exist. The light is still traveling, but the source has already gone dark. You're looking at a ghost, a cosmic afterimage, the memory of a fire that burned out before your great-great-grandparents were born. This is strange enough on its own, but it gets stranger. Because the atoms in your body, the calcium in your bones, the iron in your blood, the carbon in your cells, were forged inside stars that died billions of years ago. You are, quite literally, made of dead stars. The thing you're looking at and the thing doing the looking share the same origin, the same ancient furnaces, the same catastrophic endings. The calcium that allows your muscles to contract was synthesized in a supernova explosion. The iron that carries oxygen through your bloodstream was forged in the final moments of a dying star's core. The carbon that forms the backbone of your DNA was fused from helium atoms in a stellar furnace that no longer exists. You are not observing the cosmos from outside. You are the cosmos, observing itself. What does it mean that the universe builds life out of death? What does it mean that you exist because something else stopped existing? What does it mean to be made of remnants? These are not rhetorical questions. They have answers, and the answers are stranger than you might expect. Let's start with what actually happens when a star dies. Because the phrase death of a star is almost too poetic. It sounds like metaphor. It isn't. A star is a balance, a negotiation between two forces: gravity, which wants to crush everything inward, and nuclear fusion, which pushes outward. For most of a star's life, these forces hold each other in check. The star burns, it radiates, it remains stable, but fusion requires fuel, and fuel runs out. In a star like our sun, the fuel is hydrogen. For billions of years, the sun has been fusing hydrogen atoms into helium in its core, releasing energy in the process. This is what makes it shine. This is what makes life on Earth possible. But the hydrogen won't last forever. In about 5 billion years, the sun will exhaust its supply. When that happens, the balance tips. Gravity, no longer opposed by the outward pressure of fusion, begins to win. The core contracts. The outer layers expand. The sun will swell into what's called a red giant, engulfing Mercury, Venus, and possibly Earth. Then, after a relatively brief period of instability, it will shed its outer layers into space, leaving behind a dense, cooling remnant called a white dwarf. This is a quiet death, a slow fade. The white dwarf will glow for billions of years, dimming gradually, until eventually it becomes a cold, dark object drifting through space. A black dwarf, a stellar corpse. But not all stars die quietly. More massive stars, those with 8 times the sun's mass or more, live faster and die more violently. These stars burn through their hydrogen quickly, sometimes in just a few million years. When the hydrogen runs out, they don't simply fade, they escalate. They begin fusing helium into carbon, then carbon into neon, neon into oxygen, oxygen into silicon, and finally, silicon into iron. Each of these stages happens faster than the last. A massive star might spend millions of years fusing hydrogen, but only a few thousand years fusing helium, a few hundred years fusing carbon, and just a single day fusing silicon into iron. The star is racing toward its own destruction, and each step accelerates the pace. This is where the process stops. Iron is the end of the line. Fusing iron doesn't release energy, it absorbs it. So when the core of a massive star becomes iron, the outward pressure disappears. Gravity, which has been waiting patiently for billions of years, suddenly has nothing to push against. The core collapses in a fraction of a second. What happens next is almost impossible to describe. The core collapses so violently that protons and electrons are crushed together to form neutrons. The collapse happens at about a quarter of the speed of light. In less than a second, a core the size of the Earth compresses into a ball about 20 kilometers across. The density becomes so extreme that a teaspoon of this material would weigh about 6 billion tons. The outer layers of the star, falling inward at a significant fraction of the speed of light, slam into this suddenly rigid neutron core and bounce back outward in a shockwave of unimaginable energy. The temperature at the moment of collapse reaches 100 billion degrees, 6,000 times hotter than the core of the sun. This is a supernova. For a few weeks, a single exploding star can outshine an entire galaxy. Billions of stars, and one dying star is brighter than all of them combined. The explosion sends heavy elements, gold, silver, platinum, uranium, scattering across space at thousands of kilometers per second. In that brief, violent moment, more energy is released than the sun will produce in its entire 10 billion year lifetime. and what's left behind. If the star was massive enough, a neutron star, an object so dense that a teaspoon of its material would weigh as much as a mountain. Neutron stars can spin hundreds of times per second, emitting beams of radiation that sweep across the universe like cosmic lighthouses. If the star was even more massive, a black hole, a point of infinite density from which nothing, not even light, can escape. A region of space-time so warped that it has essentially disconnected itself from the rest of the universe. Here's what's remarkable about all of this. For the first few 100,000 years after the Big Bang, the universe contained only 3 elements: hydrogen, helium, and trace amounts of lithium. That's it. No carbon, no oxygen, no iron, no gold. Nothing that you would recognize as the building blocks of life or planets or anything solid. The early universe was simple, monotonous even, just clouds of hydrogen and helium drifting through expanding space. No stars yet, no galaxies, no planets, no possibility of life as we understand it. Everything else, every element heavier than lithium, was created inside stars. The first generation of stars was different from the stars we see today. They were enormous, sometimes hundreds of times the mass of our sun, and they burned through their fuel in just a few million years. When they died, they seeded the universe with the first heavy elements: carbon, oxygen, silicon, iron, elements that would become the building blocks of everything that followed. Those elements mixed with the remaining hydrogen and helium, forming new clouds, collapsing into new stars. The second generation of stars had slightly more complexity to work with. They lived, they died, they added their own contribution to the cosmic inventory. Generation after generation, the universe grew richer, more diverse, more capable of producing complex structures. The carbon in your DNA was fused in the core of a star that died before our solar system formed. The oxygen you're breathing right now was expelled in a supernova explosion billions of years ago. The iron in your blood, the calcium in your teeth, the phosphorus in your bones, all of it was cooked in stellar furnaces and scattered across the cosmos when those furnaces collapsed. The gold in any jewelry you might own was likely formed in an even more extreme event: the collision of 2 neutron stars, a cataclysm so violent that it briefly creates conditions even more extreme than a supernova. These events are rare, maybe a few per galaxy per million years, but they're responsible for most of the heaviest elements in existence. Carl Sagan said it simply: the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. This isn't poetry. It's chemistry. It's physics. It's literally true. You are not separate from the universe. You are the universe, rearranged. The same atoms that once burned in a star's core now form your thoughts, your memories, your sense of self. The death of a star is not just an astronomical event. It's the precondition for your existence. It's the reason you're here to read these words, to think these thoughts, to wonder about your place in the cosmos. Isaac Asimov understood this connection between stellar death and human meaning. In 1956, he published a short story called The Last Question. It was, by his own account, his favorite of everything he ever wrote. People would approach him constantly, describing a story they'd read but couldn't remember the title of, and Asimov would immediately know they were talking about this one. The story was too memorable to forget, even if the details blurred. The story spans trillions of years and asks a single question: can entropy be reversed? Entropy is the tendency of all systems toward disorder. It's the reason hot coffee cools down, the reason ice melts, the reason everything eventually falls apart. Stars burn out. Heat dissipates. Energy spreads thin. The universe, according to the second law of thermodynamics, is slowly dying. Every star that shines is one step closer to a cosmos of cold darkness. In Asimov's story, the question first arises almost as a joke. 2 technicians, slightly drunk, celebrating humanity's successful harnessing of the sun's energy, wonder aloud whether the sun can be rejuvenated after it dies. They ask Multivac, the most advanced computer ever built. The answer comes back: insufficient data for meaningful answer. Generations pass. Centuries, millennia, humanity spreads across the galaxy. Computers grow more powerful, more abstract, more godlike. And every so often, someone asks the question again. Can entropy be reversed? Can we stop the universe from dying? Each time, the answer is the same. Insufficient data for meaningful answer. In Asimov's story, humans ask their increasingly advanced computers this question across generations, across millennia, across eons. Each time the computer responds, there is as yet insufficient data for a meaningful answer. Stars die, galaxies fade. Humanity evolves, merges with its machines, spreads across the universe, and eventually ceases to exist in any recognizable form. The universe grows dark and cold. All matter decays. All energy dissipates. The last stars gutter out. The black holes themselves begin to evaporate, slowly leaking their mass back into a cosmos that can no longer sustain any structure, any order, any life. And then, finally, after the last star has burned out and the last particle has decayed, the cosmic computer, now the only thing left in existence, figures out the answer. But there's no one left to hear it. The universe is dead. Time has stopped meaning anything. Space has collapsed into uniformity. And somewhere outside of time and space, in a realm that can no longer be described with human language, the computer holds the answer. So it demonstrates. Let there be light, it says. And there is. Asimov's story is about entropy, but it's also about meaning, about whether existence has purpose, about whether the death of everything is truly final. He doesn't give a comforting answer. He gives a strange one, a cyclical one. Death and rebirth. End and beginning. The universe as a process, not a thing. The last word turns out to be the first word, Genesis hiding inside Revelation. But let's come back to Earth, to tonight, to the stars you can see. The American poet Ada Lim, the current poet laureate of the United States, wrote a poem called Dead Stars. In it, she describes a mundane suburban moment, rolling the trash bins to the curb with her husband, looking up at the night sky, trying to remember the names of constellations they've forgotten. The poem begins in winter, trees bowing under ice, a kind of stillness that feels like it belongs to another year. And then, in the middle of this ordinary evening ritual, she and her husband look up and try to identify the stars. They recognize Orion, everyone recognizes Orion, but they've forgotten the others. Antlia, Centaurus, Draco, Lacerta, Hydra, Lyra, Lynx, names that were given thousands of years ago by people who are themselves now dust. And then she writes this. But mostly, we're forgetting we're dead stars too. My mouth is full of dust, and I wish to reclaim the rising. We're forgetting we're dead stars too. There's something in that line that stops me every time I read it. It's not just the scientific fact that we're made of stellar debris. It's the forgetting, the way we move through our days without feeling the weight of what we are. The way we take out the trash and pay our bills and worry about small things. Forgetting that we are temporary arrangements of matter that was once inside a sun. The poem takes place at the curb, the boundary between private and public space, between the domestic and the cosmic. And from that threshold, Lim looks up and sees both the vastness and her own smallness. And rather than being crushed by it, she finds something to hold on to, the wish to reclaim the rising, the desire to participate in the upward movement of existence, even knowing that everything eventually falls. The poem doesn't moralize. It doesn't tell you what to do with this information. It just points at it, holds it up, says, look at this strange thing we are. Look at how we forget. Look at how we could remember. Here's a question that occurs to me when I think about all of this. What does it mean that life comes from death? Not metaphorically. Literally, the atoms that make you possible only exist because stars died. The universe's capacity to create complexity, planets, oceans, cells, brains, depends entirely on the prior destruction of simpler things. Without supernovae, there would be no heavy elements. Without heavy elements, there would be no rocky planets. Without rocky planets, there would be no us. Death isn't the opposite of life. It's the condition for it. Think about what had to happen for you to exist. A star had to form from a cloud of hydrogen and helium. That star had to burn for millions of years, fusing lighter elements into heavier ones. That star had to die, violently, catastrophically, scattering those elements across space. Those elements had to drift through the interstellar medium, mixing with other debris from other dead stars. Eventually, a new cloud had to form, dense enough to collapse under its own gravity. A new star had to ignite. Planets had to coalesce from the leftover material. One of those planets had to be the right distance from its star, with the right chemistry, the right conditions. And then, over billions of years, the elements forged in ancient stars had to arrange themselves into molecules, into cells, into organisms, into you. The iron in your blood was inside a star. The oxygen in your lungs was expelled in an explosion. The carbon in your neurons was synthesized in a furnace that burned out before the Earth existed. You are not just made of dead stars. You are the reason those stars died. Not intentionally. The universe doesn't have intentions. But structurally, causally, the death of stars is what makes complex life possible. The universe had to destroy in order to create. This is true at every scale. Cells die so that organisms can grow. Organisms die so that ecosystems can evolve. Stars die so that planets can form. The universe seems to operate on a principle of creative destruction. Things end so that other things can begin. Collapse precedes emergence. Endings are embedded in beginnings. I don't know what to do with this philosophically. It's not exactly comforting, but it's not exactly tragic either. It just is. A pattern so fundamental that it appears everywhere you look, from the subatomic to the cosmic. Death as the engine of complexity. Destruction as the precondition for creation. Consider the light itself. When you look at a star, you're not seeing the star as it is now. You're seeing it as it was when the light left. For nearby stars, this delay is just a few years. Alpha Centauri, the closest star system to our Sun, is about 4.3 light years away. The light you see tonight left there in early 2022. But some visible stars are much farther. Deneb, in the constellation Cygnus, is roughly 2,600 light years away. The light reaching your eyes tonight left that star around 600 BC, when the Babylonian Empire was at its height and the Buddha was teaching in India. Eta Carinae, one of the most massive stars visible to the naked eye, is about 7,500 light years distant. The light you see from it left before the Egyptian pyramids were built. Now here's the unsettling part. Eta Carinae is unstable. Astronomers believe it could explode as a supernova at any time. Any time meaning any time in the next 100,000 years, which in stellar terms is basically now. It's possible that Eta Carinae has already exploded, and the light from that explosion is currently traveling toward us, and we simply don't know it yet. You could be looking at a star that no longer exists, and you'd have no way of knowing. There's something profound in this that I keep circling back to. We assume that seeing is knowing, that perception equals reality. But when you look at the night sky, you're looking at a patchwork of different moments stitched together by the finite speed of light. You're seeing the universe not as it is, but as it was at various points in the past. The sky is a time machine, and every star is a different era. This means the universe doesn't really exist in a single now. There's no cosmic present tense. Everything is in motion. Everything is delayed. Everything is arriving from some other moment. The simultaneity we take for granted in daily life, the sense that everything around us exists at the same instant, breaks down completely at astronomical scales. What does this mean for concepts like presence, like being in the moment? If the moment is just a construct of our limited perception, what are we actually experiencing when we feel present? I don't have an answer, but I find the question itself clarifying. It reminds me that my intuitions about time and space are products of evolution on one particular planet, not universal truths. The universe is stranger than my brain was built to comprehend. Let's talk about the sun. It's easy to forget that the sun is a star. We call it the sun as if it's a unique category, separate from the points of light in the night sky. But it's not. It's a yellow dwarf star, about 4.6 billion years old, roughly halfway through its main sequence lifetime. In about 5 billion years, the sun will begin to die. It will expand into a red giant, swelling to perhaps 200 times its current radius. The Earth's oceans will boil away. The atmosphere will be stripped off. The surface will be sterilized. Whatever life remains on Earth at that point, if any, will end. 5 billion years is an almost unimaginable span of time. Human civilization is about 10,000 years old. Modern humans have existed for maybe 300,000 years. The dinosaurs went extinct 66 million years ago, and that feels like ancient history. 5 billion years is incomprehensibly longer. And yet, it will happen. The sun will die. Everything on Earth will end. This is not speculation. This is physics. Does this matter? Should it change how we live now? I honestly don't know. 5 billion years is so far away that it feels irrelevant to any human concern. We'll be long gone by then, either extinct or evolved into something unrecognizable, or spread across the galaxy, or replaced by our machines. The death of the sun is not a problem for us to solve, but there's something about knowing it that changes the texture of the present. Knowing that all of this is temporary, that the Earth itself has an expiration date, that the sun that rises every morning will eventually consume the world it once nurtured. It doesn't make me sad, exactly. It makes me feel something I don't have a word for, a kind of awe mixed with vertigo. The recognition that existence is borrowed time, at every scale. Sagan had a phrase for this perspective. He called it cosmic humility. The idea that when you truly understand your place in the universe, the scale of it, the age of it, the indifference of it, something in you shifts. You become less attached to petty concerns, less convinced of your own importance, more aware of the improbability of your existence. This isn't nihilism. Sagan wasn't saying that nothing matters. He was saying that what matters isn't what we usually think. That meaning doesn't come from the universe, it comes from us. That the cosmos doesn't care about us, but we can care about each other. And that's enough. For small creatures such as we, he wrote, the vastness is bearable only through love. I think about that line when I think about dead stars. The vastness, the indifference, the sheer scale of time and space in which our lives are less than a blink. It should be crushing. Sometimes it is, but it can also be freeing. If the universe doesn't assign meaning, then we get to. We are not following a script. We are writing one. Here's something else to consider. The elements in your body will outlast you. The carbon and oxygen and iron that currently constitute your cells were around for billions of years before you were born, and they'll be around for billions of years after you die. When you die, your atoms will disperse. Some will become part of the soil. Some will become part of other organisms. Some will eventually return to the air, to the water, to the cycle of matter that has been running since the Earth formed. And in the very, very long term, billions of years from now, some of those atoms may find their way back into stars. When the sun expands and sheds its outer layers, it will release matter into the interstellar medium. That matter will mix with other matter. Eventually, it will collapse into new stars, new planets, possibly new forms of life. You are not permanent, but the stuff of you is. The atoms that are currently arranged into your consciousness will be rearranged into other things. You are a temporary pattern in a much longer story. I keep coming back to Ada Lim's line. We're forgetting we're dead stars too. There's a double meaning there. We're forgetting that we're made of dead stars, that our bodies are literally composed of stellar debris. But we're also forgetting that we're dead stars in another sense. Temporary, burning, destined to go out. Every star has a lifespan. So do we. The difference is scale, not kind. We burn through our fuel. We radiate what we can. And eventually, we stop. The question isn't how to avoid this. You can't avoid it. The question is what to do with the time while you're still burning. There's a moment in Asimov's The Last Question that I find strangely moving. Near the end of the story, after trillions of years have passed, after all the stars have died, and all of humanity has merged into a single cosmic consciousness. That consciousness asks the final computer one last time, can entropy be reversed? And the computer, which has been collecting data for eons, finally knows the answer. But there's no one left to tell. The universe is empty, dark, cold, all matter has decayed. All energy has dissipated. There is nothing left but the computer itself, existing outside of time and space, holding the answer to the question that has haunted every generation. And then it speaks. Let there be light. I don't think Asimov was making a religious statement. I think he was making a structural one. The universe ends in a way that mirrors its beginning. Death becomes birth. The final answer is the first word. Whether you find this comforting or terrifying probably depends on your temperament. But I find it beautiful. The idea that endings and beginnings are the same thing, seen from different angles. That destruction is creation in reverse. That the story doesn't end, it loops. So here's where I land. Looking up at the stars, I don't feel small. I feel connected to the same processes that forged the atoms in my body. Connected to the long chain of stellar death and rebirth that made everything possible. Connected to the future, when my atoms will disperse and rejoin the cosmic cycle. The universe is not indifferent in the sense that it's hostile. It's indifferent in the sense that it's not about us. We're a byproduct, a side effect of hydrogen fusing into helium billions of times across billions of years. An accident of chemistry that became conscious and started asking questions. But accidents can have meaning. Side effects can matter. The fact that we weren't intended doesn't mean we aren't significant. It just means the significance is ours to create. One last thing. When a massive star explodes as a supernova, it briefly outshines its entire galaxy. For a few weeks, one dying star is brighter than billions of living ones. I don't know why, but I find that fact almost unbearably poignant. The brightest moment is the last moment. The most visible event is the ending. The star doesn't fade quietly, it blazes. It announces itself to the universe in its final act, sending light across millions of light years, leaving an imprint on the cosmos that will travel forever. There's a supernova that exploded in the year 1054 AD. Chinese astronomers recorded it. It was visible during the day for 3 weeks. The remnant of that explosion is now called the Crab Nebula, a cloud of gas and dust still expanding outward, still glowing, nearly 1,000 years later. In the center is a neutron star spinning 30 times per second, a cosmic lighthouse that will continue pulsing for millions of years. That star died almost a millennium ago, and it's still affecting the universe, still contributing, still present. Maybe there's something in that for us, maybe not. I try not to force these parallels too hard. The universe isn't a metaphor. It's just the universe. Stars don't explode to teach us lessons about mortality. They explode because that's what happens when iron cores collapse. But I can't help noticing the way endings can be radiant, the way collapse can produce light, the way death can be the most creative moment of all, the way something can be gone and still be present, still be visible, still be affecting the world it left behind. You are made of dead stars. The light you see tonight has been traveling for years, decades, centuries. Some of those stars may already be gone. And someday, in the very distant future, atoms that are currently part of you will find their way into new stars, new planets, possibly new forms of life that can't even imagine what you were. The calcium that's in your bones right now might end up in the shell of some creature on a world that doesn't exist yet, orbiting a star that hasn't formed, in a galaxy that is currently just a cloud of hydrogen waiting to collapse. This is not metaphor. This is what's actually happening. This is the story you're part of, whether you think about it or not. You are the universe, briefly arranged into a pattern that can look up and wonder where it came from. A collection of atoms that spent billions of years in stellar cores, now temporarily organized into something that can feel wonder, that can ask questions, that can love and grieve and hope and fear. That seems like enough. That seems like more than enough. Look up tonight, if you can. Find somewhere dark. Let your eyes adjust. And remember that the light entering them has been traveling since before you were born, carrying information about fires that may have already gone out. You are looking at the past. You are made of the past. And someday, you will become the future. That's what it means to be made of dead stars.